Hey guys, so I want to do a video on the GHS algorithm. So I already wrote the Humblet Spira algorithm, where the goal is to find the minimum spanning tree. If you don't remember what the minimum spanning tree is, the minimum spanning tree is the tree where the weights are the small. So the total sum of weights are the small. So the subtree of any graph where the total subweights are the smallest. So I already wrote here the time complexity and the message complexity. So the time complexity is O of n times log of n, and the message complexity is O of m times log of n. Okay, so m it's the edges and it's the vertices, just if you don't remember. So anyway, the algorithm goes as follows. We have our graph here, and now for the first step, we choose all the vertices. So remember, each vertex works like a computer, and then each vertex choose his smallest neighbor. Okay, so A chooses D, B chooses E, C chooses E, G chooses E, F chooses D, and D chooses A. Okay, so and then what happens? Each one either get a message connect me, or like connect, for example, D get a message from F to connect him to him, and A get a message connect me, but he also send a message to D connect me to you. Okay, and they have like a communication where they say, A, my smallest weight I want to connect to D, and the smallest weight is 5. D says to A, hey, I want to connect to you, and my smallest weight is 5. Anyway, then what happened? After that, we have two trees, okay? And there is a proof to says that there cannot be any cycles here, so there is no situation like that. Okay, it cannot happen. And basically you can think about that if he has the smallest here and he has the smallest here, it cannot happen that also he have the smallest here and here. So if this is x, this is y, and this is z, if x is less than y and y is less than z, meaning z less than is bigger than z is bigger than x and y. So you can think about it like that. Anyway, so we have two trees, and now what happened? They decide on the leader, and the leader is basically, for each one of them, is the one who says connect me to you. Okay, so D, the leader is A, and A, the leader is D. Okay, and we assume that they choose the leader by the same if they have like the same one. Okay, so they either says, okay, A will be the leader because he has no neighbors, or D will be the that leader because he has two neighbors, and he is the one who is connected to another one. Okay, so it's one of the other, but it doesn't really matter. So you choose a leader, and for example, here they choose A as the leader, and here is C. They choose a leader, and then the leader, now he's gonna manage the tree. So he basically discovers the trees and says, okay, who can I connect to which is not on my tree? Okay, so who can I connect to? And then he finds out, okay, so we have these two. This is the leader C and A. We can see them here, and here is the subtrees. And now each one of them says who I can connect to, which is not a leader. So C says he cannot connect to B because he's already in his tree. Okay, he asks E, can you connect to someone else? And he says, yeah, of course, I can connect to D, connect to F, but my weights will be 15 and 8. B says, yeah, I can connect to A, okay, or to D, but the weights will be 7 or 9. And who else? G says, yeah, I also can connect, but the weight will be 11. So C, which is like the main computer, now decides, you know what? B, you connect him. Okay, you asked for a connection, and the same thing also happened with B. Okay, with A, sorry. He asked all his neighbor, who can I connect to? He asked D, he asked F. Okay, but he never get like a positive answers. And then when they agree on the same one, they connect and created a tree. Okay, so guys, I hope you like this video. Before first of all, subscribe, and I just wanna explain this one to you. So why it cannot happen where you have 3 like this. Okay, so let's say the weight here is Z, here it's X, and here it's Y. So let's say A, B, and C. Okay, so if A chooses X, okay, and C, one second, and C chooses A, okay, we want to prove that no matter what, B will have to choose A also, X, sorry. Okay, so let's prove it. So what does that mean? If C chooses A, what does that mean? That Y is less than Z. And if A chooses X, meaning X is less than Z, that means that X is less than Y. That means Z is for sure bigger than X. Okay, so this is why it doesn't matter which graph you choose, you're gonna always have like a tree. Okay, there's have to be one edge, one connection where they choose the same one. I will really appreciate it, and until next time, I'm out.